Pop! Let's solve multi-step equations. So here's, multi-step inequalities. So here's the big thing. We're doing inequalities now. We've been doing all this stuff on solving equations. Now we're going to talk about inequalities. And basically, everything's the same. We still have to simplify like we did on inequalities. We still have to have a step 1, get rid of the constant. And we still have to have a step 2, get rid of the coefficient. The only thing that changes happens to do with when we multiply or divide, we have to keep track. It doesn't mean every time, but when we multiply and divide, we have to keep track of signs. And what I mean by that is if I gave you a true statement, like an inequality like this, and I said 5 is greater than 3. That's a true statement. You're like, okay, cool. 5 is greater than 3, I agree. But what happens is, if I multiply or divide by a negative number, and this should be a review, so say I just decide I'm going to multiply by -2. People say, why are you multiplying by -2? Because I chose to. So if I multiply this side by -2, I have to do it to the other side. That's a multiplication property of inequalities, because this is unequal. Same as the property for equalities, but we have to call it for inequalities. Well, if I multiply both sides of the equation, they're supposed to remain equal. So -2 times 5 ends up being, ends up being -10. And -2 times 3 becomes -6. The problem, though, is this still a true statement? No. If you look at a number line, -10 is way down here, and -6 would be somewhere over here, right? So as you go, the bigger the negative number, the more smaller it is. So before, this statement was true, but when I multiplied by -2, the statement no longer was true because negatives kind of mess with our minds. And what is it saying you say, Ms. Garcia?
Oh, well, these negatives change the rules. So if the rules change, the sign changes.
If the rules change, the sign changes. What she means by that is we're multiplying by a negative and it changed the rule, then we got to change the sign. And so the way that we can make this true is by flipping the signs, which you always hear people say. And so now that statement is true. So 5 is greater than 3, but if I multiply by a negative, I have to flip the sign. And so now I say -10 is less than -6. That's a true statement. It's just a weird thing. It doesn't mean that all inequalities have their signs flipped. It just means if I multiply or divide by a negative number, I flip the sign. So let me show you what I'm talking about. So I'll give you a really simple one-step equation. I got -8x is greater than 72. And I go, okay, to solve our equation, I got to get the variable alone. I'm going to circle, just like I circle equal signs, I'm going to circle the inequality sign. And I see that there is a coefficient touching it. There is no constant other than 0, so I don't have to get rid of the constant. But to get rid of the coefficient, times -8, the opposite of times is divide by -8. I divide one side by -8, to divide the other side by -8. -8 divided by -8 is 1. But I don't need to write 1, I can just write x. And 72 divided by -8 is -9. Now, according to the rules, if I divide by a negative, I must flip the sign. So instead of greater than, I have to flip it to less than. And let's see. That means if I graph this, I start with the number I'm talking about. That's -9. Give me a number that's next to it. A less than is -10. Greater than is -8. I'm going to circle the 9. And then I say, okay, what is facing towards my variable? There is a mouse facing towards my variable. That means I'm going to the left, which is less. And I'm going to go pop, pop. And you say, okay, does this work? Let's see. If I pick a number less than 9, that's -10. Well, let's check it out. Our original problem was -8x is greater than 72. If I pick a number, a possible answer for x, and I say -8, and pick an answer, say I pick 10, -10, because that is less than 9. -8 times -10 becomes +80. Is 80 bigger than 72? And the answer is check, that works. So by flipping the sign, I made this a true statement. Now if I hadn't flipped the sign and left it like this, if I picked a number greater than -9, well, I could have picked -8. That's greater than 9. If I put that in there, 8 in there, well, -8 times -8 is +64. And guess what? Is that a true statement? Is 64 greater than 72?
No.
No. So this is why we flip the sign. We flip the sign to make the statement true. So just know, only flip the sign though if you're multiplying or dividing by a negative. So here's another problem. I have 10 is greater than or equal to negative x. Or if I'm looking at the x, I have x is less than or equal to, negative x is less than or equal to to 10. So to solve this, I circle the variable. And somebody say, aren't I done? Well, the answer is no, because of that negative sign there. I got to remember that I have a -1 coefficient in front of that, because there's always a creeper touching it. You just got to, sometimes you don't have to worry about it, sometimes you do. There's my -1. How do I get rid of times -1? I divide by -1. I divide this side by -1. I divide that side by -1. -1 divided by -1 is 1. And now I don't have to write the 1, because if it's positive, we don't have to worry about it. And 10 divided by -1 is -10, but I divided by a negative, so I need to flip the sign. So I flip the sign, it was greater than, now it becomes less than. And now when I go to graph it, I go, okay, the number I'm talking about is -10, a number less than it is -11, a number greater than this is -9, same increments. I circle the variable the number I'm talking about. That equal sign says it's equal to, so like in the last video, we just fill it in, and then I look at the variable and I say, what is facing towards the variable? Is it a mouse or a gator? And it looks like a gator is facing towards my x, so gator is greater. Gator is greater. Hey, less is left and greater is gator. And so greater is gator, that means I'm going to be going to the right. And so I'm going to go to the right. And I fill in the arrow to let people know that this continues on forever in this direction. There's a solution. So that's the basics. Now Ms. Garcia is going to take you through the more difficult stuff.
So now let's turn it into a two-step inequality here. So first of all, we have both a coefficient and a constant this time. So same deal, I'm going to lollipop here, circle the variable, my variable is y. I'm going to underline the creepy coefficient that's touching the variable right here, double underline the constant. Now we got to get rid of both of those. First of all, we got to go 2, 1, 0. We know we got to get rid of that -15 first. Opposite of subtract 15 is add 15 here, add 15 here. We're going to end up with 7y still has not been touched. Now the other side is going to be this -7. Last step is the division. So we got to divide to get rid of this coefficient. We've got to divide by 7 here, divide by 7 here, and we're going to end up with -1 and y.
So now, flip the sign, right?
Exactly. You would think so. Looking at this, you're like, oh, well, there's a negative number right there. That means you got to flip the sign. Except the number we actually divided by was this +7. Now remember, like Mr. Craig said, we only have to flip the sign if we are dividing by a negative, not if we end with a negative. So since we divided by a positive number, we are going to keep this exact same sign the way it was to begin with. And just to quickly graph it real quick, we've got tiny little number line. We only need 3 numbers here. We've got the one we're focusing on, -1 in the center, 1 smaller, -2, 1 bigger is a 0, because remember, these are in the negative numbers. I'm going to go ahead and circle the one we're starting at, double check, make sure, yes, we do have a line under this, which means this -1 is included. I'm going to fill that in. Now we got to ask, is it a mouse or a gator that is looking at our variable? The mouse is looking at the variable, and since the mouse is smaller than a gator, that's going to be less to the left. Fill in our little arrow here. Very good. Ooh, more complicated one. Okay, so this one is one of those examples that you're really going to want to use SADMEG for. And I'm short, but I'm writing it up at the top here.
I'm so proud of you.
Oh, hush, you giant. All right, so first step in SADMEG is subtraction and addition. The problem is this is a fraction, and we know fractions have grouping symbols around the numerator and the denominator. So for subtraction and addition, I can't do anything with that 1 until I get those parentheses, well, gone. So let's move to the next part. We've got division and multiplication next. Now we do have a division that we can get rid of. So how do you get rid of division? You multiply. We need to give...
Do it to the other.
Thank you, Mr. Craig. I almost forgot to do it to the other side. So if we're dividing by 3, we gotta multiply by 3 to get rid of it. Multiply 3 to the other side to, keep it even, keep it balanced. 21's over here. 1 minus 2n is over here. And since it's no longer a part of a fraction, we no longer need the parentheses, but I am going to go ahead and include this. The reason being, notice, we did multiply, but we multiplied by a positive 3. So the sign stayed the same, so I'm going to write it again to remind myself that it is the same thing so far. Notice I said so far. Back to SADMEG, we already undid the grouping symbols. Back to subtraction and addition. Let's get rid of the 1. That 1 is positive, so we're going to subtract it to get rid of it. Subtract 1 right there. Oh, I need a longer lollipop. And 20. Once again, sign is the same, and I'm going to write the sign again just to remind myself. Last step, get rid of the coefficient by dividing. We're going to divide this by -2, divide this by -2, and hold up, I just said divide by a negative, didn't I? And when we divide by a negative, that means we actually have to
Flip the sign!
Really wanted to say that, so let's flip it, the sign right here. Now, the mouse is looking at the variable instead of the gator is looking at the variable, which means we flipped it. So, quick number line once again. 3 little dots. All right, so we've got the -10 in the middle, 1 smaller, -11, 1 bigger, -9. All right, circle on the 10. Double check to see if we include it, which we do. So we're going to include the -10. Mouse is looking at the variable, which once again means we are going to the left.
Less is left.
Less is left. Absolutely. All right, that arrow's filled in enough, I think. Once again, we have a fraction, so we're back to SADMEG.
So sad.
You know, for being so sad, she's very helpful.
Well, we're making her unsad by solving.
There you go. All right, first of all, lollipop, may as well start it off that way. Indeed. Remember, fractions are grouping symbols. Can't do nothing with the numerator until we get rid of the -2. So, skipping straight to division and multiplication, I guess. We're going to multiply this -2. Multiply this by -2. These are now a 1. We don't have to worry about them. X plus 5. Other side, 3 times a -2 is a -6. Now, this is where I would draw the sign. But, did something happen?
Multiplied by -2.
We multiply by a -2, and if we multiply or divide by a negative, so it's both of those, that means what do we have to do to the sign?
Flip the sign!
Flip the sign! All right, we have flipped the sign, and now we can go on knowing that we have got the sign correct. Subtract the 5 here, subtract the 5 here, because this is our constant. Whoops, there we go. What?
How come I don't flip the sign? I did a negative.
Well, that's a subtraction by a negative? No, we are subtracting here. Just because a negative is there does not mean we need to flip the sign. It is only when we multiply or divide by a negative. Here, it was subtraction. Even though we ended with a negative, we're still okay. The sign has not changed. Quick graph once more. Little tiny graph. 1, 2, 3, -11, -12, and -10. All right, this time, circling the 11, but it is not included, so we're gonna leave that circle open. A mouse is looking at that variable, which means smaller again.
Less is left.
You know, I've done 3 smaller ones in a row. Are you trying to tell me something, Mr. Craig? Am I that small?
I'm just saying.
All right.
Math doesn't lie.
All right, Mr. Craig, take it away.
All right, so I wanted to give you one of these crazy ones. And the reason why I wanted to give you one of these crazy ones is because, and by the way, you might notice that we're going pretty fast. It's because you can hit pause, rewind, and rewatch it until you get everything you need from the equation. So, we've been doing SADMEG to solve equations, and that's because it's supposed to kind of make it easier. And so, according to SADMEG, I would add or subtract first. The problem is that if I add 3k to this side, I'm actually making this problem more difficult because I'll end up having variables on both sides. And I don't want variables on both sides. So in some cases, we want to go right to SADMEG. In other cases, we want to simplify first. That's at step 0. And simplify first is when I do GEMDAS. So again, GEMDAS is when I simplify. SADMEG, which is GEMDAS backwards, is when I solve. I solve to both sides. GEMDAS, when I simplify, I do to the side that I'm working on. So I look at the side. According to GEMDAS, I do grouping symbols first. So I look over here on my chart. I have some grouping symbols. I can't add them, so the way to get out of grouping symbols is the distributive property. So I'm going to go an area model, and and I'm going to say 2 times k. That gives me 2k. And then 2 times 4 gives me 8, right? And now that's a positive 8. And now I can bring that down. 2k plus 8 minus 3k is less than or equal to 14. And again, I could go to solve, but then I'd end up with my variables on both sides, and we don't want that. What I could do instead is keep on simplifying, because sometimes simplifying just makes more sense. I did my grouping symbols. I don't have any exponents. I do have multiplication and division, or multiplication, but I don't know what k is, so I can't do it. And finally, I can add or subtract. And if I look at adding or subtraction, I can see that I have 2 like terms that I can add together because I have identical variables. 2k minus 3k is negative 1k. And I'm actually going to write the 1 this time because I don't want to lose that negative sign. So I'm going to write that negative 1. I don't have to. I could put just negative k, but some people get kind of confused by that. So I'm going to write that down, bring down my 8. And now there's nothing less that I can simplify. So now I have to solve. And so before I solve, though, I'm going to identify all my parts. K is my variable. That negative 1 is my coefficient because it's touching the k. And that makes this 8 my constant because it's on the same side of the equation as my variable, but not touching it. So then I go to SAD make now and say addition or subtraction. Right there, get rid of the constant. So I minus 9 to both sides. Subtraction property of equalities. 8, oh, what'd I do 9 for? Hello, hello! You mean minus 8, Mr. Craig? Yeah, we all make mistakes once in a while. I just do it more often than most. All right, so plus 8 minus 8 is 0, but I don't need to write that 0 down because I have this negative k here. And I'm going to put a negative 1k, and that's less than or equal to. I don't need to flip the sign because I'm subtracting, not multiplying or dividing. This is going to give me 6. 14 minus 8 is 6. And then finally, I think I'm done, but then I have that negative 1 there, and that means, according to SAGMAN, I have to get rid of multiplication or division. So I have to divide by negative 1, and if I divide one side by negative 1, I have to divide the other. Division property of inequalities. And negative 1 divided by negative 1 is positive 1, and I don't need to write that because the 1 is just there. And 6 divided by negative 1 is negative 6. But I divided by a negative 1, and so if I divide by negative 1, what do I have to do?
Flip the sign!
Flip the sign! Which means I have to make it go the other direction. And so I get k is greater than or equal to negative 6. Quick graph on that. 3 lines, only need 3. The number you're talking about goes in the middle, that's negative 6. A number smaller than that is negative 7 on the number line. And a number bigger than that is negative 5. Those are the same increments. I'm talking about negative 6, so I start there. I put a circle. I check. I see that it's also equal to. That means I'm filling it in. And then I look at my k and say, is there a mouse or a gator facing it? There's a gator. And a gator is greater. Well, it just rhymes. I just love that. Gator is greater. Greater is greater. Greater, gator, greater. All right, that means I'm going to the right because gator is greater and greater is to the right. So I go, you have to make that sound. It kind of sounds like a turkey. It just makes you happy when you do problems. And so I get, this is my answer. All right, that completes this video. If you have any questions, please email us. See you on the flip side.